Right, the Goldilocks Universe. The Goldilocks Universe is shorthand for the surprising fact that many of the constants that are discovered in physics and other scientific theories are there seems to be no good reason for them being so perfectly adjusted to the existence of life as we know it, as they are. Now, there are two competing theories or philosophical viewpoints that I'd like to compare and contrast to explain the Goldilocks universe. The first one we might call the intelligent design theory. This is the theory that God made the universe the way it is. He's a loving God, he's a perfect God, and he designed the universe to be perfect for life. He did it specially for us. The other theory is the atheistic theory, which tries to do away with God and say, well, this must have arisen naturally, but they can't come up with any particular reason why these constants should be so perfect. So to fit into quantum theory, the theory has been put forward that there are actually multiverses. There's many universes, possible universes, and the fact that we live in one that's perfect for life is not surprising, since we wouldn't live in one that wasn't perfect for life. We would be dead. So it's just a statistical fact that we live in a universe which is perfect for life. It's called the anthropic principle. Now, I don't find either of these two theories particularly convincing. The anthropic principle seems to me like a good cop. Goldilocks comes up to the anthropic principle. She says, well, I can't understand why the universe is so wonderfully well designed for me to be in. The anthropic principle says, there's an infinite number of universes out there, and it's not surprising that you live in the one that's perfect for you, because you are in the one that's made you. And Goldilocks goes up to the intelligent design theory and says, I can't understand why the universe is so perfect for me. Intelligent design theory said, well, God made it that way, just be grateful. It's good cop, bad cop, and it's just not convincing. The idea that physics is pointless and that God just made things the way they are, well, that doesn't cut the icing on the cake anymore. But the idea that there is an infinite number of universes and it's a statistical blip that we have, it's not scientific. The whole point of science is that it comes up with a beautiful theory that explains the facts, and that's not a beautiful theory at all. No, I don't agree with either of them. At this point, I'd like to put forward a metaphor, if I may, from maths, which is what I'm most familiar with. The metaphor I'd like to put forward is, consider the strange case of division. Now, I don't know whether you've thought about this before, but when you divide, say, 12 by 3, what do you mean by that? There are two competing possibilities for what you mean by that. You could mean, how many 3's go into 12? 3, 6, 9, 12, 4 3's go into 12. That's one possibility. The other possibility is that you might mean how many are in 1/3 of 12. If you divide 12 into 3 equal pieces, how many are in that one of those equal pieces? Now this seems to be a good metaphor to me. There are two competing possibilities there. One of them has one explanation, another one has another explanation for this seemingly happy coincidence. But actually there's something deeper underlying this. And that something deeper is the commutativity of multiplication. Now, multiplication is a particular operation that obeys a commutative law. That means that a times b equals b times a. 3 times 4 equals 4 times 3. This is unusual. A lot of operations don't follow commutativity. And I can say 7 take away 3 is not the same as 3 take away 7, for instance. But multiplication does follow commutativity, and that is why 12 divided by 3 is the same whichever way you think of the division operation. Right, here we go. This is 12 divided by 3. As you can see, it's shared into 3 equal pieces, the horizontal lines. And there are 4 in each. Or you can think of it as how many 3's fit into 12 as the vertical lines. And because the commutativity, because they both the length times the width and the width times the length equals 12, these two things are essentially meaning the same thing and have the same answer. Now I think this points us in the direction of what the answer is. The belief in God is an axiomatic sort of thing. It's not something you can argue. It's not something I can say, well, this proves God or this disproves God. It's something you've got to say, I believe in or I don't believe in, and follow the consequences of that. See where it takes you. An example of this in mathematics is the axiom of parallel lines in geometry. For a long time it was the mathematicians tried to prove that parallel lines never met. Eventually it was realised that that's just an axiomatic statement. I mean, parallel lines never meet under normal circumstances on a flat piece of paper, for instance. But if you say parallel lines can meet, you get a closed surface like a sphere where the lines of latitude, the lines of latitude meet at the North Pole and the South Pole, and these are technically parallel lines. So depending on what axioms you accept for geometry, you end up with a different geometrical surface. This is how mathematics operates. Depending on what axioms you accept as being the basic axioms, you build up different mathematical structures. And I think it's likely the same with God. Depending on how you choose your God to be, you will end up with a different universe that you're living in. If you choose a bloodthirsty God, like the ancient peoples did, many of them, you will end up living in a bloodthirsty universe where people have to kill each other, like the Romans had. This is the axiomatic view of God. It's what you base your life on. So that is my explanation as to why we're living in a Goldilocks universe. Now, it might be mind-boggling that your decision to believe in God or not will affect the physical constants of the universe. and that's not really how it works, because our science is based on our view of the universe. But this is a philosophy of science question, really. But I'd like to point out that it's certainly not much different from the quantum universe picture, which sees the observer as being part of the system, and therefore the system collapses to a waveform depending on how it's observed, and this gives rise to the multiple universe way of looking at quantum mechanics. This is not much different from what I'm saying.